Yeah, let's go with that. Anyway, back again. Part of my actually don't point by, don't care. Kind of doing one of my other classes right now. Yeah. So right now I'm going to talk about bandwidth in physical layer of OSI model. Like I said before, I hate the OSI and TSP, IP bullcrap, IE bullcrap stuff. So pardon me if I interrupt myself. No, screw out. I'm going to be interrupting myself throughout the video anyway. All right. What I am gonna first, I'm gonna tell you what I'm doing. I do most of my classes online unless I had to go in for like a course test or qualification test. I don't do anything else, nothing but online or like a 4 or 5 week or less than that. I do not do anything, even engineering. I hate that bull crap. Regroup, got here. I hate it. Um, so unless my class is like, if it's like mostly online, I have to go in like once or twice for an indoor course, fine. Other than that, no. Mostly Sierra. Anyway, um, bandwidth to speed. Now, bandwidth is speed, like I said in my encoding video, signaling video, whatever the video was called. Now, the video itself didn't go in depth based on speeds. Like literally, when I get into depth with it, I will explain to y'all because I did it years ago. I actually worked jobs. I literally worked every job for crappy pay or douchebag people while with a damaged body. So I don't care. Usually I'll do like, was it 5 jobs that liberated or 5 jobs, 5 jobs that liberated, 2 or 3 jobs that was staffing, and then when I get into pro staffing, usually take about 1 or 2 jobs for me to get what I need to do or the amount of money I need to get qualifications. Um, unit of bandwidth. This is how most pay for my classes at the class, or whatever. Anyway, units of bandwidth. Um, I'm going to go from the slowest and the smaller amount of bandwidth down to the largest. We're not going to get quad board crap because no one got a quad computer. First is bytes, not no, bits, not bytes. Bytes are bigger than bits, so bits are smaller than bytes. Bits is BITS, bytes is BYTS. Don't even ask me why it sounds two different douchebags. I know. Crap, now I'm bits per second is how many bits in 1 second travels. 1 bits per second is the basic smallest unit of bandwidth. If you have bits on your PS4 or your game system, you're getting slow internet. The next level is kilobits per second. It's basically 1,000 bits per second, and depending on how form of a scientific notation where you're gonna put it, I'll leave my notes up. After kilobits, everyone should have megabits by now, even Africa or Australia or even though it doesn't the people of South America or stuff in the middle of nowhere should have this by now. Megabits per second. Mega in term of bandwidth is a million. Now, I'm gonna confuse y'all because bits usually mean 1, centobits is 100, millibits is 1,000, kilo is like keep going up. Like, yeah, confusing, right? Anyway, Megabits is 1 million bits per second. Gigabits per second. I had giga. I actually had tetrabyte in it before I moved up, and now I moved up here, and people screw me over. Anyway, gigabits per second is 1 billion bits per second. Fast, I know, right? Tetrabits per second is trillion bits per second. That's fast internet. But anyway, now when you get into like bytes, internet speed, have you gotta adjust some of that down by 1, and then you get the standard read of it. And you gotta be careful when you got a network internet speed. Cause if you internet speed your ISP, don't use a stuff. Use someone else. Keep it simple. Now, the bits, reason why I told you the bandwidth speed, because I'm going to the RSI model. I'm gonna talk about this how it works using the RSI model from me to you. There's a physical layer, the me and you, the computer, the PS4. And there is the hardware where the CAN rule is activated between you and the computer, between you, CAN rule, and the hardware. When you put in a address and send it out, that process go to in a bit format. You're gonna start right there. Once you send that information out, the data link layer will end up encoding those bits with a header of what you want, the header you want to go to, the data of their want, and that trailer is going to go to. Then it goes up to the network layer where a packet is added. The last layer develop a frame. Those data is then converted into a packet. That packet holds the IP address. Yeah, I know. This is why I don't like it. That packet would now just have a header and data in the network layer. And a data link layer, it just had header, data, and trailer. All right. When you go from the network layer to the transport layer, you have data. And transport layer, it gets into segments to make it easier to break apart. And this is where the bandwidth come in. Wink. Then you go into the session layer where it's started communications. But it's not where the start is, it's just the session. Like make sure it's still there, control it and stuff. Then it goes in presentation layer on the other person or other destination, presenting what you want. And then it goes to application, pulling the application down from that end. And that end, starting from their physical layer, coming back down to your application layer on your end. This is a physical. Yeah, confusing. I know. Anyway, that's the end of that craziness. Bye.